Hi Chem 20s, Mr. Riley here with another Chem video for you. As you can see, it's still cold in Edmonton. So we're going to talk about a concept in chemistry that is called percent yield. If you look in the first page of your data booklet, you're going to see these two formulas. We're going to talk about the top one first, and this is percent yield. So what percent yield basically means is that I can do stoichiometry to predict how much product I'm going to produce in a chemical reaction. But when I actually do the experiment and try to produce that product myself, it might be a little bit different than what I predicted in my stoichiometry. And that's where this calculation comes in. So percent yield is basically a comparison of how much I expected or my theoretical value that I calculated in my stoich to my actual or my experimental value that I got from my experiment. Usually these numbers are not the same, and they're almost never the same. There are several factors that can contribute to this difference. Is the reaction 100% complete? Is it just a slow reaction and it needs to take a really long time? Did we lose a little bit of our precipitate or our product as we're transferring it and trying to measure it? Are the reactants, are they both 100% pure? And all kinds of things can lead to different amount of product than what you'd expect. And that's why usually when we do an experiment, we're going to calculate the percent yield. So let's pretend that we're doing this experiment. So this is an example from your workbook. So here's the question. It says when 1.84 grams of strontium nitrate is mixed with excess copper 2 sulfate in a solution, a precipitate of strontium sulfate is produced. So we want to calculate the percentage yield of this investigation if experimentally I obtained 1.50 grams of strontium sulfate. So that 1.50 grams, we're going to save that to the end. That's our experimental value, or from our formula, what we would call the theoretical, or sorry, not the theoretical, the experimental value. Okay, now the theoretical value is the one that we are going to calculate. It's be our expected quantity of precipitate that we're going to get from doing a stoichiometry problem. So let's do that now. And with any stoich, we need a balanced chemical equation. So we're going to have strontium nitrate. Strontium is a 2+, nitrate is a 1- polyatomic ion. So we're going to end up with SrNO3. We need 2 of those NO3s, and that's going to be in aqueous solution. We're going to react that with copper 2 sulfate solution. So copper 2 and sulfate is a 2- polyatomic ion. So we're going to get CuSO4, and that's an aqueous solution. And just a little note on that it says excess here. So copper sulfate, we're being told here's the excess reagent. There's going to be lots of it extra that aren't used up. It's the strontium nitrate that's going to determine how much precipitate or product that I produce. It's the limiting reagent. Okay, and so that's what we're going to use. And so my products here, this is going to be a double replacement reaction. And so my products I'm going to have here are going to end up being strontium sulfate. Both are 2 ions. So SrSO4. Okay, now that is going to be our precipitate. So we could check our solubility table. We'll see that's low solubility. It's our solid. And then our other product is going to be copper 2 nitrate. And it's going to look like that, and that's going to remain aqueous. So when I mix these two solutions, I'm going to produce a solid, and you guys know that that's our precipitate, and a lot of times that's what we'd be looking for in this chemical reaction. So there's our precipitate. So now let's find our theoretical or expected quantity of our precipitate that's going to be produced here. So I know I have 1.84 grams of that reactant, and I want to figure out what mass of this reactant I'm going to have. So this is a mass-to-mass stoichiometry. So we know that we're going to need our molar mass. So I calculated my molar masses of these ahead of time. My molar mass for strontium nitrate is 211.64 grams per mole. And my molar mass of my precipitate, my strontium sulfate, is 183.69 grams per mole. And so I'm going to need to do a mass-to-mass stoichiometry here. It's all a 1-to-1 ratio. I didn't mention that, but it's already balanced because my anions are the same charge and my cations are the same charge. So it's a 1-to-1 ratio here. So let's start with our given, right? This is our given. Okay, our precipitate is our required. And so I'm going to start with my 1.84 grams of SrNO3. I'm going to convert that to moles. Okay, I always want to convert my given to moles, and so I want moles, and I have grams. Okay, that's my molar mass. This conversion factor is my 211.64 grams per 1 mole. Okay, once I get that, now I can use my molar ratio. And some of you guys are at the point where you can kind of skip this step. It's 1-to-1 ratio. So, 1 mole of my SrSO4 for every 1 mole of my SrNO3. Okay. These cancel, these cancel, these cancel. At this point, I'm dealing with moles of strontium sulfate, my precipitate, and then I'm going to convert this back to mass because I want to know what is the mass of this product. So I want grams, and I have moles, and every mole of SrSO4 has a mass of 183.69 grams. And now I'm dealing with grams, and I plug this all into my calculator. How am I doing for time here? Jeez, it's going a bit long here. We're going to be okay. Come on, turn on. So we're going to have 1.84 times by 1 over 211.64. Okay, and then multiply by 1 over 1. We can kind of skip that step, and then I'm going to multiply by 183.69. And I get my answer here. It's 1.59700. And so I'm not going to round this value to sig digs and anything quite yet because this is still an intermediate step. I just want to know my percent yield here. So to find my percent yield, okay, I'm going to compare. So this value right here, this is my theoretical. So theoretically, if everything was 100% pure, if I was like Walter White, mixing these chemicals, I would get 100% purity, 100% yield. But usually that's just usually doesn't happen. So that's my theoretical value. So my percent yield, I'm going to be comparing. If I go back up to my formula here, my experimental value to my theoretical value. Okay, so my experimental value from my question was 1.50 grams of strontium sulfate. So 1.50 grams divided by my 1.597 grams. I did pretty good. And I'm going to multiply that by 100 to get a percentage. So when I put that into my calculator, I'm going to do 1.50 divided by my answer and multiply that by 100 to get my percentage. and I got 93.92%. Let's just say we got 93.9% yield in this experiment. So I'd say I did a pretty good job in the experiment. I should mention here that there's also a measurement that we can make of percent error, and percent error is a calculation of sort of how far off you are from your theoretical value. And so to do that, we would take the experimental value, subtract the theoretical, divide that by the theoretical times 100. And so what we would get, we could just take 100%, subtract 93.9, and so we would get a percent error of 6.1% here. So that's how far off we were from our theoretical value. Okay, so there is percent yield. Hopefully you guys found that helpful. I will see you next time. Good luck.